Hi! This is a different day of ed puzzles yet again because you already know this stuff and now it's just practicing it. I will advise you at the beginning of this, the space given in this first problem for A, B, C, D, and E is not quite enough. I know I had to go to a second piece of paper, so if you have a second piece of paper, you should go to that. If not, write small so you can fit on all these parts. You may be able to put it around here or something else, but just letting you know. Okay, so go through this on your own. The only time I'm going to stop you is between page 149 and 150. You can skip through as needed to the other parts. So in here it says find the average velocity from t equals 1 to t equals 2 seconds. And I should read the context. For the stem of the problem here is a particle moves along the x-axis, meaning it's boring. It moves right and left. So that its position at time is greater than or equal to 0 is given by this function. So we're given the position function, and we know that position is measured in feet and time is measured in seconds. So that will help for our units. This one is no calculator permitted, which actually becomes pretty cumbersome really quickly. So just be careful. All of this can be done without a calculator. It's just a little difficult, but try to not use your calculator. Okay, part A, if you need help with that one. If you're finding average velocity, velocity is the rate of change of position. So you should be thinking, what is the position function? Well, that was P of t. So I'm going to take P of 2 minus P of 1, that's where I'm at, divided by 2 minus 1. This will give me the change in position, which is measured in feet, the change in time, which is measured in seconds. I get feet per second as my unit for velocity, which makes sense. The average rate of change is the slope of the secant. That's what we're doing here. You have to show your work though, because this is without a calculator. Don't just do this in your head. I would actually write down the position at 2 and figure out what that value is. Position at 1, figure out what that is. In part B, I want to know when is the particle moving to the left. Before I ever started this problem, I actually wrote down my reasoning for this. The particle moves to the left when v of t is less than 0. So I wrote this down and I said which occurs on the interval, and then I left this part blank. And then I did the rest of the work. So I already did my justification before I ever found out it was the interval from 0 to 3. So on this one, to figure out when a particle is moving to the left, we need to figure out, well, when is a particle potentially changing positions? Meaning when is velocity equal to 0? So I'm going to find p prime of t, that's velocity. So I'm showing that I know that by writing that. Finding that derivative, setting it equal to 0, factoring. You can kind of see how I did this work over here, but if you do it a different way, that's okay. You're factoring, and I get t is equal to 3 and t is equal to negative 1/3. In this problem, it was given at the very top that t is always greater than or equal to 0. Most problems time is greater than or equal to 0, but it was given as that, so that's not on the interval. So I'm only checking from 0 to 3. I need there's a change in position at 3, and then 3 to infinity. For this particular problem, if I choose my favorite number between 0 and 3, let's say 1, and I put it back into v of t, you get that this is negative. If I choose my favorite number from 3 to infinity, and I substitute it back into velocity, I find this is positive. Because I wanted when velocity was negative, I already said that up here in my justification, 0 to 3 is when my particle is moving to the left. Pause this video as needed. In part C, if I want to use appropriate units to find p prime of 3 and p double prime of 3, and this is based on these values, describe the motion of the particle. So if I'm saying, okay, p prime of 3, what is that? Because I'm going to have to describe the motion of the particle. That's just the velocity at 3. So it's the instantaneous rate of change of position, which is velocity. P prime of 3 is equal to v of 3, and we already found velocity before, so now it's just a matter of substituting in. So it was this function right here. Substituting in, and we find the velocity at 3 is 0 feet per second. For p double prime, we haven't found that yet. So I found p double prime of t before I could find it of 3. That's just the derivative of velocity. The derivative of velocity would be 6t minus 8. That's written down here. Substitute in 3, and you end up getting 10 feet per second per second. Make sure to indicate units of measure in these. P double prime of 3 is the same thing as acceleration. I should have put that somewhere over here. Acceleration at 3. There we go. So I'm showing what I know in my reasoning. It's helping me, it's helping whoever is reading this in order to grade it. So if I say, if I want to know what's going on with the reason, I'm going to say as v of 3, or p prime of 3, because that's what it was asking about, equals 0 feet per second, that means the velocity is 0 feet per second at time t equals 3. So the particle isn't moving left or right, it's stopped at that moment. But the acceleration is still going. So it's kind of like if you're going somewhere in a car and you're on a straight path and you're going and then you have to reverse. You're already in that process of reversing, but you had to stop, and then there's a moment where you stop before you change direction. This is where it's 0, but there's still a force being put on your car. Same idea here. So there's still a force being put on this particle, but the particle is stopped only momentarily. Part D, it asks about maximum velocity. Maximum, this is the absolute maximum velocity. For continuous functions, which this one is because I know that v of t, we found it before, it was just 3t squared minus 8t minus 3. That is just a parabola, it's continuous. For continuous functions, by the extreme value theorem, and you don't have to write this part, but I did, that the maximum values can be found at endpoints or where the derivative is 0 or does not exist. But in this case, the derivative, there's no place where the derivative does not exist. So what I want to do is I want to figure out what are the endpoints. So I'm going to find the velocity at 0 and the velocity at 3. We actually already found the velocity of 3 to be 0 feet per second. The velocity at 0 we can substitute back in here. Velocity at 0 and substitute, and we find negative 3. But we also have to find anywhere the derivative is 0. Be careful, we're finding maximum velocity, so we're using the acceleration function. So we find v prime of t, which is just the 6t minus 8. We set that equal to 0, and I get t is equal to 8/6, or I said 4/3. Then I have to substitute this back into the velocity function. Velocity at 4/3. And this is hard because I'm not using my calculator. I got to the point where I got 16/3 minus 32/3 minus 3. That'd be like negative 16/3 minus 3. What I know is it's lower than negative 3. And I can see 0 is higher than that. If I want the maximum, I'm just choosing the y value that's the biggest. This is 0 feet per second. The max velocity is 0, which occurs at t equals 3 seconds. So I'm given lots of information here. The last one is talking about finding the total distance. Again, this is hard because we don't have a calculator, so we have to do a little bit more work. Total distance, you have to consider when is a particle moving left and right. So a particle is moving to the left when velocity is negative, to the right when the velocity is positive. This is where I needed a new page. Here's my work for this one. I figured out the velocity, or p prime, was 0 at t equals 3. And we actually did this over here before. This is where I got this work from. T equals negative 1/3 was not on that interval. And this is talking about on the interval from 1 to 5. So I feel like this keeps changing a little bit. So the only place that the position is changing directions, so I should say that the particle is changing directions, could potentially be at 3. I don't actually care whether I'm moving right or left or right or left. It would be easy to figure out based on what we've done so far, but I don't care. Actually, I think we already figured out that it was left and then right, but I don't actually care. What I care about is those intervals. So I'm going to say the position of 3 minus the position of 1, and then take the absolute value of that change in position. This is where I'm getting 12 from. Over here, the position of 5 minus the position of 3. This is where I'm getting 11 minus negative 17, and I get 28. I add those two distances together to get a total of 40 feet. That was a lot. That was all 149. I'm going to go over 150 also. In 150, if you're checking your work right now, I'm hoping that you noticed before that the calculator was permitted on this one. But I'm going to go through some of my reasoning on this when I'm giving you my answers. So I'll move this up so you can see my answers if you just want to check. I'm going to do my best for my hand to not get in the way. There we go. In the first problem, it says find the average acceleration. You're given velocity. To find acceleration, acceleration is the rate of change of velocity. And this is average acceleration, so it's over an interval. Think slope of the secant line. So this is where the v of 20 minus v of 5 over 20 minus 5 is. And if you're not sure if you're saying the right thing or if you should have done a derivative or something else, what you can do is use your units to help you. These units for velocity were given in miles per minute. The denominator was just in minutes. This was from my chart. 4.5 minus 9.2 over 15. The 4.5 minus 9.2 was miles per minute. 15 was just minutes. Miles per minute makes sense for acceleration. I'm allowed to use my calculator, so this is where I got this final answer from. If you wanted to leave this just as a fraction, you could do that also. In B, there are two ways to do this, so you don't have to have everything that I have, but you do have to have the first part. This question says, based on these values, is the acceleration of the plane guaranteed to equal 0? Guaranteed, as soon as you see guaranteed, I actually circled mine. As soon as you see guaranteed or is there a value, justify that there is a value, you should be thinking, I'm using a theorem. And to use any theorem, you have to state the conditions. Okay, so acceleration is equal to 0, and I'm given velocity. Acceleration is the derivative of velocity. So I want v prime to be equal to 0. In order for v prime to be equal to 0, what theorems am I thinking of? Either mean value theorem or rules. One of those two. And either one of them could be used here. They're just slightly different in the ways that you write them. So if you used mean value theorem or rules, the very first thing is you need to say is v of t is given as a differentiable function, therefore continuous on this interval, and continuous on the closed interval, by the mean value theorem. And I changed this from brackets to parentheses. It should be parentheses because that c, whatever the c is going to occur within that interval, like not at the endpoints. So by the mean value theorem, if you use that one, from 25 to 30, or I use this over here from 0 to 15, I just saw the 25 to 30 first, there exists a c such that, this st means such that, v prime of c equals the acceleration in c equals 0. So yes, this is a place. But your reasoning in this one, so my conditions were differentiable, therefore continuous, which is true for rules or mean value theorem. But if you're going with mean value theorem, you have to say something like v of 30 minus v of 25 over 30 minus 25 equals 0. And I should even write equals a of c. Same thing over here, equals a of c. Or you could say v prime of c. That would be fine also, since we already said v prime is equal to a of c. If you use rules, the conditions aren't just continuous and differentiable. You also have to say f of a is equal to f of b. So you have to say something like v of 25 equals v of 30, or v of 0 equals 15. Well, both. v of 25 equals v of 30, and v of 0 equals v of 15. And then you can just jump to the answer, and you can say, therefore, by Rolle's theorem, we know there's a place where v prime of c is equal to 0. Or you could have said a c is equal to 0 because we already wrote that they're equal on the intervals 25 to 30 and 0 to 15. Okay, so that was a theorem. Moving on, in C it says, does the data represent velocity values of a plane moving away from its point of origin or returning to its point of origin? So this one we have to see what's happening in this. And if I look at velocity, I can see all of these are positive, which means right now, if velocity is positive, that means the position of the particle, the position is moving to the right. Even if all of them are negative, and we could say to the left, it would be moving away from its point of origin. But because all of these are positive, v of t is positive for all values 0 is less than or equal to t is less than or equal to 40, therefore the plane is moving away from its point of origin, meaning it just keeps going further and further from where it started. Same thing if they were all negative, but they're all positive, which means the plane is moving away. If it started to be negative partway through, then that's when it would be returning. And the last one, it says we've got this function defined, and it gives that long function, f of t is equal to 6 plus cosine of t over 10 plus 3 sine of 7t over 40. And then it says find the acceleration. Again, you have to know and to write down that f prime of t is equal to acceleration. And this problem, I know when I did it the first time, I actually took the derivative by hand, but then I used my calculator afterwards. Save yourself that step, because if you forget that the chain rule exists here and you forget to multiply by 1/10, or you mess something up here and you forget to multiply by 7/40, or you do something crazy, it's going to mess up your whole answer. So I would say just go to your original function. I'm going to try to get it out of the glare. And you can say this, do math, and then go down to the end deriv. You could also do this in your graph, but we haven't done it this way for a while, so I'm just putting it in. I changed it to ddx, 6 plus cosine of x over 10. Then I'm closing this, plus 3 sine of 7x over 40. And then that closes it. And I want to know what's happening at x equals 23. And I get negative 4.076, which you could have said negative 4.08 if you truncated, because 6, you know, if we're rounding appropriately, but I just truncated, meaning I counted off after the 7. And make sure that you put appropriate units. For acceleration, you're taking the rate of change of the velocity, so you'd say miles per minute, and then it asks what does that mean about the particle, or about the plane I should say, and this one it wasn't a, I think I said particle before, this is about a plane. As acceleration is negative at t equals 23, that means velocity at t equals 23 is decreasing. Whew, that was a lot of me talking. Please let me know where I can help you, if I can help you. Yeah, I think you're awesome. Thanks so much for working. I appreciate you. For real. Have a great day.